Honoring a legacy Richter Scale Day, every year on April 26th we observe Richter Scale Day, a day dedicated to understanding earthquakes and the scale that measures their intensity. This day serves as a reminder of the immense power of nature and the importance of scientific advancements in helping us comprehend and prepare for seismic events. Earthquakes, while often destructive, are a natural phenomenon that shapes our planet. By understanding the Richter scale and its significance, we can better grasp the forces at play beneath our feet. Richter Scale Day is not just about commemorating a scientific tool, but also about acknowledging the ongoing research and efforts in seismology, a field dedicated to studying earthquakes and mitigating their impacts. It is a day to appreciate the scientists and researchers who strive to unravel the mysteries of Earth's dynamic nature, ultimately contributing to safer and more resilient communities.
Measuring the Earth's tremors, the Richter scale. The Richter scale, also known as the Richter magnitude scale, is a numerical representation of an earthquake's magnitude, reflecting the energy released during the seismic event. Developed in 1935 by Charles F. Richter and Benno Gutenberg at the California Institute of Technology, this groundbreaking scale revolutionized our ability to quantify and compare earthquakes. Prior to its introduction, scientists relied on subjective descriptions and less precise methods to assess an earthquake's strength. The Richter scale employs a logarithmic scale, meaning that each whole number increase on the scale represents a tenfold increase in the amplitude of seismic waves and approximately 31.6 times more energy released. For instance, an earthquake measuring 6.0 on the Richter scale is 10 times more powerful than a 5.0 earthquake and releases significantly more energy. This logarithmic nature allows the scale to encompass a vast range of earthquake magnitudes, from minor tremors barely perceptible to humans to catastrophic events capable of causing widespread devastation.
Charles Richter, the man behind the scale. Charles Francis Richter, an American physicist and seismologist, is the namesake of the Richter scale. Born in 1900, Richter's fascination with earthquakes began during his time at the California Institute of Technology, or Caltech. Working alongside Benno Gutenberg, he developed the now famous Richter scale, a tool that would forever change the field of seismology. Richter's contributions to earthquake science extended beyond the development of the scale. He dedicated his career to studying earthquakes, their causes, and their effects. His work laid the foundation for modern earthquake monitoring and hazard assessment, ultimately contributing to our understanding of these powerful natural phenomena.
Section 4. Deciphering the numbers. How the Richter scale works. The Richter scale quantifies earthquake magnitude by analyzing seismograms, records of ground motion produced by seismometers. These instruments detect the vibrations caused by seismic waves as they travel through the Earth. By measuring the amplitude of these waves, specifically the maximum displacement of the ground from its resting position, seismologists can determine the magnitude of the earthquake. The process involves calculating the logarithm of the wave amplitude, corrected for distance from the epicenter, and comparing it to a standard reference earthquake. The resulting number represents the earthquake's magnitude on the Richter scale. It's important to note that the Richter scale is an open-ended scale, meaning there is no theoretical upper limit. However, the Earth's physical limitations suggest that earthquakes significantly larger than those already recorded are unlikely. Section 5. History's tremors earthquakes on the Richter scale. The Richter scale has been instrumental in recording and understanding some of the most significant earthquakes in history.
The 1960 Valdivia earthquake in Chile, the largest earthquake ever recorded, registered a staggering 9.5 on the Richter scale, releasing an immense amount of energy that caused widespread devastation and triggered a tsunami that affected the entire Pacific Ocean.
Another notable event was the 1906 San Francisco earthquake, which devastated the city and had an estimated magnitude of 7.9. This earthquake highlighted the destructive power of seismic events and emphasized the need for earthquake-resistant infrastructure and preparedness measures.
The 2011 Tohoku earthquake and tsunami, with a magnitude of 9.0, showcased the devastating consequences of underestimating earthquake and tsunami risks. These events, along with countless others recorded on the Richter scale, serve as stark reminders of the importance of understanding earthquakes, their potential impacts, and the ongoing need for scientific advancements in earthquake preparedness and mitigation.